President.
Thank you, sir. Good afternoon, ma'am. Ma'am, first of all, from the Department of CSC, Sri Vishnu Engineering College for Women, we welcome you to this conference and thank you so much, ma'am, for accepting our invitation as a keynote speaker for this conference. Before entering into the session, let me take the privilege to introduce you, ma'am. It is my great privilege to introduce Srimati SSSN Usha Devi. She is now working as Assistant Professor of Department of Computer Science, University College of Engineering, JNTU, Kakinada. Srimati Usha Devi has completed her BTech in CSC from JNTU, Hyderabad, MTech in CSC from University College of Engineering, JNTU, Kakinada. Now she is pursuing PhD from National Institute of Technology, Trichirappalli. Srimati Usha has published 68 papers in various international journals, conferences, and authored 3 textbooks on artificial intelligence. She has filed a patent on deep learning. Her research interests includes deep learning, cloud computing, and big data. Thank you so much, ma'am, for giving your time to spare your valuable insight to our participants. Now the platform is yours, ma'am.
Thank you, sir, for your nice introduction. Is the screen is visible now?
Yes, ma'am.
Other participant is also sharing some screen, it seems to be.
Yes, yes.
Madam, can you reshare the screen, please?
Okay, yes, sir, yes.
Sir, I stopped her sharing, sir.
Okay, sir. I think now this. You can go for a full presentation, madam.
Is it visible now, sir?
Yes, but you go for full presentation. F5, press F5 or something like that.
Okay, I'm keeping in slideshow mode only. Is it visible now?
Yes, ma'am, it is visible.
Okay, thank you. So today, am I audible, sir? Am I clear?
Yes, ma'am, you are clear.
Okay. Today, I would like to discuss reinforcement learning methods. So these are the points I would like to discuss on today's session: motivation, what is reinforcement learning, and what are various applications, types of machine learning, Q-learning, deep reinforcement learning, and reinforcement learning challenges, and summary of the session. So motivation. So this is a case study where I would like to find out the best route from one city to another city, Kakinada to Tiruchirappalli. So how to find a best route? So initially I need to see the possible routes. So in Google Map, I found 2 routes here. So one is in gray color, the flight way, and second one is in blue color, right? That is a roadway. So this is a gray color, this is blue one. Okay. So these are the 2 static routes I found. So from these routes, I can find one as best one. So suppose if I travel using this bus route or this roadside road route in the first experience, so I may feel I might have different experience. So it may be good experience or bad experience. The reason is maybe due to the traffic, due to the road path, because those are different parameters where they are going to change dynamically. So the road path is going to be normal in this time. So after rainy season, it is going to be get damaged, right? So due to that, that path is not comfortable. So next time I might choose this flight mode. The reason is the previous bad experience. So like that, based on my experience, the previous experience, I need to change my decision. So my decision is not going to depend on the static parameters now. I need to consider the traffic, like a dynamic parameters like a traffic, the path, the type of the path or type of the road, or the COVID area. Now there is one more parameter. In Google Map, I can see all these parameters, all these dynamic parameters. I can decide my route. So previously we used to apply path selection techniques like premise algorithm or Kruskal algorithm on static routes. But when the parameters are dynamic, definitely we need to move to some other technique. Here, so in this case study, how a human is able to learn and take a decision based on experience. So it is going to explain this. So human, he has multiple routes. Now this person is going to decide one route among multiple. So based on trial and error method. So initially he is going to select one route based on trial and error. He performs the action. That means he travels from one city to another city, and he observes whether it is a success or failure. Suppose if it is a success, so without any issues, he is able to reach the destination. That is success. So failure means definitely he got very bad experience based on some parameter. So that is recorded as failure. So he is going to record the experience based on this result, success or failure. So next time he is going to move to the next trial. So based on his previous experience. So of course, a continuous travel is not possible. Like immediately we can't travel to the same source to same destination. So here, so it may be done after some time in the next trial. So reinforcement learning here, just we need to substitute a human, substitute a agent, an artificial agent in place of human. Here reinforcement learning is a mimic of human decision making. So if we substitute a human with this artificial agent, now this artificial agent needs to decide the path based on the trial and error method. Further, to represent that trial and error method, it's going to have set of states and actions. So every state is associated with a certain reward. So here artificial agent is going to learn the total environment based on this state movement, rewards, and respective actions. Next, it has several applications like home automation, production, and autonomous drivings, and so it's going to be applied on several streams. So two popular applications I'm going to show now. So IBM Watson Jeopardy 2011. So here IBM Watson applied reinforcement learning to win the Jeopardy game. It's happened in the year of 2011. It competed with human. So in another application, Go Alpha. So Go is one game, one sort of game. So here we can see the checkboard, right? So this is Go game. It won the prize in the year 2016. It competed with one human expert. So these are two popular applications. So whether this reinforcement learning is a popular throughout the world, and if I observe this Google trend, so reinforcement learning based on this keyword reinforcement learning, China people, so they are using this keyword regularly and it got 100% usage when compared with other countries, whereas India you can see 2%. Of course, the remaining countries also fall in this 2% only. So it is not that much popular. That means the theory part is available, but applications are not available. People are not regularly using this work on reinforcement learning. So types of machine learning. So till now we have seen how the human brain thinks to take a decision, then how the reinforcement became a simulation of human decision making, and then now we are going to see types of machine learning methods. Here the basic types of machine learning: supervised, unsupervised, and reinforcement. Supervised learning. So in supervised learning, the model is going to learn based on a labeled data set. This is called a labeled data set. So here played represents label. When the temperature is mild, outlook sunny, humidity 80, and windy is no, then played yes. So this is called one pattern. So here hot, and temperature hot, outlook sunny, humidity 75, windy is yes, then played no. So in this situation, it is not possible to play the game. So it is going to represent such type of patterns. So in supervised learning, the machine learning model learns from labeled data set. So these are various machine learning models: Bayes, KNN, K nearest neighborhood, support vector machine, SVM, decision tree. So Bayes works based on probability distribution, probability, and here K nearest neighborhood. So based on the number of neighbors, and support vector machine based on the margin. Suppose these are two different classes. So how we can maximize the distance between this particular class and this particular class? So here classification, regression both comes under the supervised learning models. So in classification, we are going to decide the class of a new pattern. So decision tree, it's like a tree-like model. For example, here, suppose temperature is normal, the windy is very less, then definitely we can go for play. Yes, so this is going to represent the label of this particular pattern. Next, regression. So linear regression problem determines a continuous value. For example, if we consider a problem like a petrol cost. So to yesterday's, that means 10 days back, it is some 100. After that, it is 101. So after that, it is 102.3. So what about today's cost? Similarly, what about today's cost? So we can predict this cost using this regression model. So next, logistic regression. For example, the points are like this. So in regression, we are going to fit a line actually. Fit the points using a line. Suppose these are the points, this is the input points. Then we try to draw a line that passes through maximum points. That is called a regression, linear regression. In logistic regression, there will be points like this. Suppose if the points are scattered like this, if you try to fit all these points, it may not cover maximum points. For this particular case, we go for logistic regression. So this is the formula. So this is the graph for the logistic regression. Next, unsupervised learning. So in unsupervised learning, the model learns the pattern based on this unlabeled data set. This is unlabeled. So there is no label here, attached here, right? So there is no SN, SR, no labels. So what kind of problems we can solve by using this unsupervised learning? For example, if you take market basket analysis, For example, there are this is the example. So ID, milk, grocery, ice creams, chocolate. We are talking about one store. So here one customer, he purchased 230 milk packets and grocery, 65 grocery items, 34 ice creams and chocolates, 89. So there might be some other, a few more rows here. So we can identify the customers with similar interests, or the customers who are purchasing ice cream and chocolates together. So like that, such a kind of inferences can be derived from this supervised learning. So example models are clustering, association, dimensionality reductions. Clustering. In K means clustering, grouping items. So in clustering, we group the items. For example, these are the points. And here these are another set of points. Then we can group the items. Like this. So where K is equals to 3, number of clusters, K is equals to 3. So density based clustering depends on number of neighbors. So here we consider the number of neighbors to perform clustering. And association. In association rule mining, we can derive patterns like, suppose people, the customers can purchase bread, milk, eggs, wheat. So these are the items. So we can derive patterns like bread and egg. That means maximum customers are purchasing bread and egg combination. Okay. So wheat, egg. So this is also another pattern in which customers are interested in. So that if we find such a pattern, then it will be helpful to the shop keepers to check the storage of these items. That means they need to maintain certain proportionate. How many wheat packets, how many eggs are there, like that. They need to maintain certain proportionate to improve the profit, to maximize the profit of that business. Next, dimensionality reduction. In dimensionality reduction, suppose we have 24 attributes in a particular data set. I'm talking about heart disease data set. So in heart disease data set, there are 24 attributes. Okay, this is a case study. There are 24 attributes. Okay, so for example, age, next gender, exercise habit, yes or no, next smoking habit, BP, sugar. So like that, there are 24 attributes. So in addition to this, there is one more like country, language, like mother tongue. What is the mother tongue of that particular patient? Okay. So there are several attributes like this. But on observation, we can identify that language and country may not determine the risk level of heart attack. So what is the output label for this data set? The output label is okay. For example, we need to identify the heart attack risk levels. So here the language and country code may not determine the patient's heart attack risk level. So it is not possible to use these two parameters. So simply we can omit such a type of attributes. But the point is, even though we remove these two, now the data set size is 22 only, 22. If you want to reduce this dimensionality, we can go for this principal component analysis, where the high dimensional data is mapped to low dimension data. It's not going to eliminate the existing columns like this. It maps the high dimensional dataset to low dimensional dataset based on the eigenvector calculation. So this is about principal component analysis. These are the popular methods in unsupervised learning. Next, coming to the reinforcement learning. So as per our discussion, so reinforcement machine learning that is similar to supervised learning only. But here we don't train with the sample data. If you consider any algorithm, any model, for example, I'm talking about a decision tree model. So initially we need to consider data set. X represents input, Y represents the output. We need to consider a data set like this. Suppose if the data set consists of 100 rows. Okay, I'm just for a case study I'm taking 100 rows. Okay, we need to divide this data set into two parts. This part consists of 80 rows. I'm dividing it like 80-20. Okay, 80 rows for training, 20 rows for testing. So 80%, 20%. Okay, so initially I need to fit the model with this known X and known Y. That is X train, Y train. So model dot fit. This is a method used to train the machine learning model. Okay, in Python programming is using sklearn package. So model dot fit X train comma Y train. So this is already known. So this input is known, and for this input, what is output? It is also known. So then I need to predict the value of Y output. Here Y represents output. The value of Y based on this input. Based on this input. So after predicting this, so we get a value. Y predict. Then I need to compare this Y predict with Y actual to measure the error. So this is the process we used to apply in machine learning model and supervised learning. When we follow supervised learning. So dividing the total data set into training and testing and fitting the model using X train and Y train and predicting the output by submitting the X test to the model and comparing the Y predict and Y actual to measure the error in the model so that we can improve the model in the next stage. But what about this reinforcement learning? So here we don't train the model. The algorithm isn't trained using sample data. So this is the difference between the supervised learning model and reinforcement learning model. So here the agent needs to learn the environment based on its experience only. So this model learns as it goes by using trial and error method. So it identifies a set of possible states, like suppose, so agent is moving from S1 state to S2 state and performing some certain action 1. And what is the reward? So what is meant by reward here? Reward means experience is positive or negative, success or failure. Okay, then next it is moving to some S3 state. Okay, by performing action 2 and reward. So now what is the cumulative reward? The summation of reward 1 plus reward 2. So movement from S1 to S3 and summation of reward 1 plus reward 2 is going to be the cumulative reward. So the agent goal is to optimize this reward. and determine a policy that if you want to get maximum profit, you move from S1 to S2 state, then S2 to S3. Like for example, here we got highest reward. We can think like that in this case. Okay, this is the highest reward. So the policy determines that. So move from S1 to S2 and S2 to S3 to get highest reward. So that is the experience of the agent. Next, features. Sequential decision making. So as we have seen before, it's a sequential decision making. Move from state 1 to state 2, next stage 2 to state 3, like that. And it is based on the hit and trial process, as we have seen before. And feedback is not immediate output, because we are computing the cumulative reward. The agent may get a delayed reward also, depending on the sequence. So whether this action is a static thing, like definitely agent should move from S1 to S2. Suppose S2 to S3. Suppose he moved from S1 to S2 by performing this action 1 with a reward 1 and A2 R2 from S2 to S3. So whether this is a static movement, it is a fixed one? No. Suppose if this experience is not good, he might change the movement. Suppose moving to S4 has given more reward, like A2 R2 plus 2, then definitely it's going to give the preference to this particular movement. So this movement is not fixed. Agent action determines the next data it receives. What is the next state? What is the next reward? Everything is going to be determined by the action and its reward. The environment is stochastic. It is not a fixed environment. It's a dynamic environment, as we have seen in previous application. So here agent, suppose the state space map may be some 64 by 64 grid. The agent may not explore all the cells. He might explore only the states that are giving a highest cumulative reward or optimized cumulative reward. Like this point to this point, this point to this point to this point, this point to this point, like that. He identifies the optimized cumulative reward. Q-learning is one example RL method. In this, before going to learn what is Q-learning, first we should know the terminology. Agent, an entity that explores an environment and acts upon it. And he learns this environment, which is a dynamic one, which is not a static one. And here action is a move taken by the agent within the environment, and state is a situation made by the written by the environment. For every action there will be a reward. So that is a feedback. It may be a positive reward or negative reward. Next, finally, we need to come up with a policy. That policy strategy applied by the agent for the next action based on current state. This policy is prepared by the previous experience, by considering the previous experience. Next, value. So it is a resultant of the move, but it is a short-term reward. So whereas the Q value is associated with, Q value is nothing but a value, but it is associated with the state. That means if the state changes, the value also changes. It's like state comma value combination. Say two-dimensional entry. So this is one example. Hello.
సునీల్ గారు వస్తుంది చూడండి.
Am I audible to you?
You're audible, please continue.
Okay. So in this Q learning environment, agent learns the environment and performs various actions and gets a movement from one state to another state by taking certain feedback. For example, here in this case, there are 4 possible states: S0, S1, S2, S3. State entry, action entry, Q value entry. S0. From S0, what are the possible states? I'm talking about directions here: east direction, south direction. Similarly for S1, west direction, south direction. Similarly for this, I'm representing the respective Q value with Q entry, QS1, QS3, QS0, like that, and so on. So what are the possible ways to move from S2 to S1? This is west direction. Sorry, this is north direction. This is west direction. And similarly here, east direction, north direction. So like this, we need to determine state, action, Q value combinations. How to update Q value? Because the artificial agent updates the Q value based on the experience, based on the reward. So how to update this Q value? So this is a Bellman's equation used for Q value optimization. In this equation, there are 2 important factors: learning rate, discount factor. So the learning determines how much Q value to be updated. So we are adding this total part alpha into this much value to update the existing Q value. If alpha is 0, that means this total component is going to be 0. QSTAT is equals to QSTAT only. The previous Q value is equals to new Q value only. That means the agent didn't learn anything new. Suppose if it is 1, agent discovered something. That is the meaning of the learning rate. If you observe another important parameter called gamma, discount factor, if this value is 0, that means max QST plus 1, that means next state profit, consider next state profit is 0. That means it's a short-term reward. It represents a short-term reward. We are not considering the maximization of this movement, okay, maximization of the profit in the sequential movements. We just consider the short-term movements. If it is 1, means we're considering the sequential movements. For long-term reward, the respective flowchart is like this. Start. So place the agent in the initial location in the environment. Select the action for the current state. Suppose like S0. So update the Q value for the state action and move to the next state. Once we move to the next state, whether that is a goal, if that is a goal, then we can place the agent in the initial location in the environment. He came to the initial location. If that is not the goal, then training epochs remain. There is further is to learn. Then we can go for the next action. So if the epochs are completed, epoch means 1 iteration. If the epochs were completed, then we can stop the learning process. So another model is deep Q model. So till now we have seen Q model, Q learning model. Now deep Q learning model. In deep Q learning model, we're going to place a deep learning model in place of Q table. This deep Q is a combination of deep learning plus reinforcement learning. So this is one example deep neural network. And this is reinforcement learning representation. So what is the importance of this deep reinforcement learning? So in gaming, in Atari 2600 emulator, the researchers tested this particular deep RL models with several games. In all these games, the deep RL defeated a human player. So that is a graph showing here. It defeated human players. So what is this deep learning? We have seen the importance of deep RL, where the deep learning as well as RL got integrated in identifying the decisions and identifying the optimizations. What is this deep learning? So this deep learning is a subset of machine learning, whereas this machine learning is a subset of AI. So here AI consists of methods, whereas artificial intelligence methods, approaches, and machine learning tells the implementation part of this AI. And deep learning uses deep neural networks for complex problems. For simple problems, for small with small data sets, we can solve certain problems. So for them, machine learning is sufficient. Suppose if the data is growing like a big data, or data varieties are more, or the problem itself is a complex problem, like image reconstruction from the blur image, then we need to go for deep learning, deep by establishing a deep neural network. So an artificial neuron is a simulation of human brain neuron cell. So this is a human brain neuron cell. How this neuron is nucleus is connected to this axon and all axon terminal. Similarly, we have an artificial neuron, and it is also connecting to certain inputs, and it is producing certain output by performing certain activation function, by applying certain function. So simple neural network versus deep neural network. So what is the difference between a simple neural network? Previously, we have seen an artificial neuron. So artificial neurons together can formulate a simple neural network. But what about deep neural network? So in simple neural network, there are less number of layers. For example, here all these neurons are connected to perform certain tasks. So the first layer is called input layer. The last layer is called output layer. In between, depending on the processing complexity, we might have many layers. Here, if we have one single hidden layer, then that is a simple neural network. If the problem is complex, then we need to include multiple hidden layers, and the input is also huge. If the input is also huge, then we need to include multiple neurons in the input layer. If the output is also not a single output, for example, if I'm talking about a heart attack risk level prediction, so it might have three outputs. Risk level is high, medium, low. So in that case, this output is going to change. For example, if I'm talking about a handwritten digit recognition, then the output consists of 9 digits actually. If the output is 1 1 9 zeros, sorry 8 zeros, then this represents the output is 0. If the input is like, suppose this is the input, okay, then it must give the output this one. Okay. Similarly, for all the 9 digits, it is going to follow the same. So here single output is not sufficient. So we need to have multiple neurons. Single neuron is not sufficient. We need to include multiple neurons in the output layer. So in deep neural network, we can observe multiple layers and multiple neurons also, more number of neurons also. And one more point is, throughout this network, we apply only one activation function. And here, from layer to layer, we can change the activation function depending on the application. So an activation function is nothing but which input needs to be considered, how to power up the input. So for such decisions, we use this activation function. So we have 3 popular activation functions called sigmoid ReLU function, leaky ReLU function, softmax function, as activation functions in deep neural networks. So one complex application I would like to show you. So it is image reconstruction using autoencoder, which is a deep neural network model. So which cannot be solved using a simple artificial neural network. So here, so the original image is going to be reconstructed based on this blur image. So deep neural networks are going to deal with such a type of complex systems, complex applications. Next, coming to this RL libraries. So how to implement RL programs. So we have various tools like PyQ learning, Keras RL, TensorFlow agents. So by using these libraries, we can do RL programming. So these are 3 popular RL libraries. So these are the definitions for metrics, actually, performance metrics. Dispersion is a basic measure. So if the distribution is stretched, so if the dispersion is more, that means we are not converging to one particular solution like this. We are not converging to a particular solution like this. That represents error only. So in reinforcement learning, how to measure the error? So based on these basic parameters, I just mentioned only 2 parameters here, but there are many parameters. Depending on the application, we need to select the metric. So here CVAR means averaging the extreme losses. So in what cases the RL deviated from the original point? So those errors can be averaged, which gives the CVR value. For example, in machine learning, we have 3 types of models: regression, classification, and clustering. To evaluate the regression model, we have sum of square errors method. It means observing the difference between y predict and y actual. Okay, and sum of squares. Yes, we need to perform RMSE, and SSC. Sum of square errors and RMSE is equals to root of y predict minus y actual whole square, and so on. So what about classification? So we use confusion matrix to measure the performance of the model. Confusion matrix. Sorry. Precision, recall, PR curves, and so on. So what about clustering? Homogeneity, completeness. So how far the clusters are. Okay, suppose if the clusters are separated maximum, then it is a good model and compared with this. Okay. So these are various metrics for machine learning models. For reinforcement learning, we need to focus on the dispersion and CVR and how many runs, how many epochs it is going to take to maximize the profit for that particular problem. Next, what are various smart city applications we can deal with? Automated vehicle parking, power grid control, traffic control, customized smartphone, smart home panel control. There are automated vehicle parking. So here also it is not a static problem, because when one person is entering into the parking, during that time another person may remove his car, maybe in the process of removing this car. So it is also a dynamic problem. So here also agent can learn the environment automatically and provide a state sequential states to move the car from actual position to the parking area. Similarly, the power grid control, traffic control, and customizes smart home panel control. So based on the customer interest, depending on the timings also, the reinforcement agent can suggest the some can give the recommendation to the customer, or it can operate as per the customer interest by observing customer interest. For example, it's like how your mother identifies your interested food based on your regular food habit, regular eating habits. So it's like that. Next, RL challenges. So here, even this is a mimic of human decision-making activity based on trial and error method. There are challenges like how to design this reward, how to identify the parameters, how to select the parameters, and are we exploring all the possible moments in the realistic environment? Of course, it is not possible because certain experiences may not happen at that particular moment. There may be certain dynamic experiences. Because here we are talking about a stochastic environment. So due to that environment cannot be learned completely. It's a non-stationary and it's a stochastic one. And too much reinforcement learning is also leading to reduce the performance of the system. So these are various challenges. So in this session, I have discussed reinforcement learning and its similarity to the human decision-making behavior based on trial and error method, and how this RL defeated human in majority of games, and several example models like RQ learning and deep reinforcement learning. So still reinforcement learning facing challenges. Here recently I have seen one mail from Kaggle competitions saying that identify the problems in IBM Watson. We have seen that IBM Watson won the prize in Jeopardy game in 2011, but still it needs to solve certain challenges, certain problems. That's why it's kept in Kaggle competition now. So still reinforcement learning facing challenges. RL is the current trend research topic to explore because in Google Trends, when we observe, many people, it means maximum people are from China only. So there is it's a really a current trend research topic to to explore in our place also. These are the references I followed. IBM, Medium website, Job Point, Towards Data Science, Neptune, Analytics India. These are very important references for learning any kind of machine learning as well as the deep learning concepts too. Disclaimer. Thank you. Any queries?
Yeah, dear participants, if you have any queries, it is open for all. You can unmute yourself and you can ask the queries. Yeah, I don't think they have some queries, ma'am, because you clearly explained about from introduction to end, point to point, you covered everything with the detailed explanation, ma'am. I hope we don't have any queries.
Thank you, sir.
Yeah, thank you so much, ma'am. Despite of your busy schedule, you shared your valuable time for us. And thank you so much for accepting our invitation and being a part of this conference as a keynote speaker, ma'am. Thank you so much, ma'am.
Thank you, sir. Thank you, sir.